So first thing I want you guys to do is just copy down these double angle identities, and then we're going to talk about how to actually come up with what these double angle identities are. We can come up with these double angle identities by utilizing the sum of two angles from the previous section. So here we have the sine of 2 times theta. We could break apart 2 times theta into theta plus theta. So the sine of 2 times theta is the same thing as saying the sine of theta plus theta. And I want you guys to think of theta as like your alpha and your beta from the previous section. And if you were to plug in theta into the sum of two angles for sine, you would end up with this right here, right? If you plug in theta and theta. And if you look at those two terms there, you have sine, cosine, sine, cosine. You have two like terms. If you add up those two like terms, you end up with 2 times the sine of theta times the cosine of theta. So that's how we come up with the double angle formula for sine. And we do that we use the sum of two angles for cosine and tangent also to prove the double angle formula for cosine and tangent. So let's think about that for cosine right now. We could break apart 2 times theta into theta plus theta. And if we use the sum of two angles for cosine, plug in theta and theta, we would end up with this here. Cosine theta times cosine theta minus sine theta times sine theta. Cosine times cosine is cosine squared. Sine times sine is sine squared. And that's how we come up with the double angle formula for sine, or for cosine, excuse me. All right, so tangent of 2 times theta. We could break apart 2 times theta into theta plus theta and use the sum formula for tangent from the previous section. Plugging in those thetas, we end up with this here. And tangent times tangent is tangent squared. Tangent plus tangent is 2 times tangent. You guys, I think that these problems right here, I think this is like problems 1 through 3 for the homework. Okay, it says in the homework to use the sum or difference of two angles to come up with the double angle formulas. You guys wrote down the double angle formula for cosine right here, but there's actually 2 other double angle formulas for cosine. And you can manipulate this double angle identity to come up with this one here, the second and the third one. So I'm going to show you guys how to come up with the second and the third just by using the Pythagorean identities. It's really pretty simple. So I'm going to show you guys how to use the first double angle identity to come up with the other two here. So the first double angle identity says cosine squared minus sine squared. And here we have cosine squared in red because we're going to make a substitution into cosine squared. We know that cosine squared plus sine squared is equal to 1. So if I were to subtract sine squared to both sides, I would end up with cosine squared is equal to 1 minus sine squared. So I could make a substitution into the cosine squared there. And if I make that substitution, I have 1 minus sine squared minus sine squared. So we have like terms here. 1 minus sine squared minus sine squared. Minus sine squared minus sine squared is a minus 2 sine squared. So that's how we came up with the third double angle formula for cosine. Now, if you wanted to come up with the second one, we would have to use the first and plug into sine squared. Bill. So to address somebody's question, how do you come up with the second one? If you were to solve for a minus sign squared, you would end up with cosine squared minus 1 is equal to negative sine squared. So if you make that substitution into negative sine squared here, you would have cosine squared plus cosine squared minus 1. You get, so if I plug into the negative sine squared, I have cosine squared plus cosine squared, which is 2 cosine squared, and then minus 1. So that's how we come up with the second one. Does that answer your question? Yeah. All right. Example 4. We're going to use a double angle identity to solve algebraically in the interval from 0 to 2 pi for the sine of 2x equals the cosine of x. We're trying to figure out what angles are going to satisfy this particular equation. So the first thing we want to do is use the double angle identity. The directions are telling us to use it, so let's go ahead and figure out which one we're going to need to use. We're going to use a double angle identity. Here we have the sine of 2x. Okay, so let's make a substitution in for the sine of 2 times x. That's a double angle identity for 2 times the sine of x times the cosine of x. And what our goal is right now, our goal is to pull everything to one side and somehow factor everything on one side and set our factors equal to 0 and solve. So let's go ahead and subtract cosine x to both sides. If we subtract cosine x to both sides, then we have 2 times sine x times cosine x minus cosine x is equal to 0. And if you look at the left-hand side of the equation, you have 2 terms that have cosine x in them. So let's go ahead and factor out the cosine of x out of both of the terms. If we factor out the cosine of x from both terms, on the inside of the parentheses, we'd be left with 2 times sine x minus 1. That's on the inside of the parentheses. So now we got 2 factors on the left-hand side of the equation. Let's go ahead and set those factors equal to 0. You got cosine x equals 0, and then you got 2 times sine x minus 1 is equal to 0. So we're going to solve for the sine of x. And if we add 1 to both sides and divide by 2, we would end up with the sine of x is equal to 1/2. So we have to figure out, for cosine of x equals 0, we have to figure out what's the angle that's going to give a ratio of 0. And then for the sine x equals 1/2, what's the angle for sine that's going to give a ratio of 1/2? So let's deal with one of these at a time. We have to, let's think about cosine right now. We've got to go to our definition for cosine first. We know that cosine's definition is x over r. So what I'm looking for right now is where does cosine, where do we have an x value of 0? Let's think about our circle. If I draw a circle, where do I have an x value of 0? 2 spots, right here and here. This is x is 0, y is -1 if the r value is 1. And right here, this is x is 0, y is 1 if the r value is 1. This is at pi over 2, 90, and this is at 3 pi over 2, 270. So the cosine of pi over 2 is 0, and the cosine of 3 pi over 2 is 0. So we have some solutions right here. We got x is equal to pi over 2 and 3 pi over 2. Those are 2 of the solutions. We're not completely done here. We have to figure out the angles that will give the sine of some angles to give 1/2. So let's go ahead and think about the definition for sine. Sine's definition is y over r. So let's go ahead and think about the different quadrants where we have positive ratio for sine. 1 and 2. Our y values in the first quadrant are positive. So we have a y value of 1 here, r value of 2 here. That should remind you of a 30, 60, 90 triangle. The side opposite of 30 degrees is half of the hypotenuse. 1 is half of 2. That means this is 60. So what's that angle measure? It's 30, but what's the angle measure in radians? Pi over 6. 180 divided by 6 is equal to 30. But we're thinking about this interval here from 0 to 2 pi. So we have to come up with the other angle. So let's think about our second quadrant as well. We have a 1 and we have a 2. And once again we have 30 here. And now we're thinking about how far we've gone. How far we've gone from 0 to this point here. From 0 all the way to this point is 150 because we're 30 degrees away from 180. So we could say 150 times pi over 180 and reduce. I prefer to look at the 30 here and say how many 30s will fit within that 150. 5 of them. 5 times 30 is 150. 30 is pi over 6. So our other solution is 5 pi over 6. Another way you could look at that is 180 is pi, and we could subtract 30, which is pi over 6, and that would give us 5 pi over 6 as well. So this is our solution.